Okay. Hi everyone. Let's get started. So today we're going to talk about classes. We're going to talk about the difference between functions and methods. Then we're going to talk about the difference between a call by value versus a call by reference. And then we're going to do a little house activity. So classes. So let's get started with classes. So a class is a way that we can generalize any kind of object. And so we might have a class of toy, and that an instance, like a copy of that toy object, would be a specific toy, like a Bop It or something like that. So like a class, toy, opening, closing, and then what might be the attributes of a toy. And so we have the public stuff, and then we also have the private stuff. So the privates are going to be pretty much all of the variables that it's going to store, and the stuff that only the inside of the toy class is going to have access to. And so this is, remember that semicolon. And so the privates might be the name of the toy, which is going to be of type string. String name. I probably need to include the string using namespace std. Okay, great. There we go. And maybe a double as the price. And you could keep thinking of more and more things. Maybe age, low age range. Let's do that. That's a low age range. So like, who's the lowest? What's the youngest person that could use it? Or let's just say lowest age. Something like that. Okay. And then the publics would be how we get that. Oh, also classes should be uppercase. How do we get all of those things? And then also we need something called a constructor. A constructor is going to be run when you make a class. Actually, have we talked about that yet? I'm going to do this without a constructor, and we'll follow up later with a constructor. So right now, the public, all the publics will be things that other people can call how people use our toy class. So we need we need getters. This is how we get, see how this actually suggests all of these. How it suggests these. We need getters for all of these. So we're going to say like get underbar name. So we're going to make a getter. And so get means that it's going to give us back the type of name. So what's the type of name? Well, it's a string. So that's going to be the return type. And it's not going to take in any arguments because we're getting something. So we return name. So that's how we do a getter, is that we match the type of the object, and then all we do is we return that object. So I could essentially just copy and paste this 3 times, and then just change all of these to price and lowest age, price, and then change these types appropriately. So this one's a double, and this one's an int. So these are all the getters. This is how we're going to be able to, after we've made a toy, and then maybe somebody set the name, price, and the lowest age, we then go through and we actually we're able to retrieve that back. But so before actually the getters, we need to have things called setters. And so these are going to be void, and they're going to change the values of all of these. So set name, and so this is going to consume a name. And so the type of the argument is going to be the same, hopefully the same type. So it's going to be like new name. And then we just say name equals new name. And this is also an opportunity for you to double check whether or not it's valid data. So let me move the slider a little bit. So what you can also do is, instead of just immediately assigning it, you can make sure that the value is correct. So let's do that, and we're going to set price. And so what's a natural constraint of the kinds of prices that you would set on a toy? Maybe you want to make sure that it's a valid value. So maybe you have like an if the new price is greater than 0, then you actually set it, and you set price to new price. And then maybe you have an else where maybe you just set price to 0. Or maybe you just leave it alone. Maybe you just leave price to whatever it was. So open, close, yeah. So essentially what happens here is this is called bounds checking, in the sense that we're checking the bounds of what price would be reasonable. We're making sure that somebody couldn't enter in like a negative value, or that something was free, for example. And so maybe if we wanted to make an item be able to be free, we would just do that, right? So somebody could set the price to 0, but they couldn't make it so that the store owns the money when they buy that toy. And at this point, we should really start commenting, especially when we have these curly braces that don't, it may not be clear. So this is the end of set price. And above each of these, we should have a comment block where we say the name of the function, what arguments it takes, and whatnot. And I'll populate, and I'll show you how to populate that. Do I have any examples? Yeah, so actually let's go to the GitHub, and let's just grab and let's look at the examples that were already provided. So let's view the file. So here we go. So here's what you essentially would expect to see. You see the name of the function right here. See, that's the name of the function. Maybe a description of what the function does, or what it's doing. So this was a recursion example, somebody asked me. And then we have this tag @params. Those are going to be arguments, or the parameters. That's what's going to be inside of here. We say the type, we say the name that it's going to be, and then maybe we specify what is it actually going to be used for. And then down here in main, we can see we have params and we have returns. So let's just copy and paste this example here. That's what we're going to use. So right here, oh, and let's just paste it on main so we have it. So right here, we see it's going to be called getName, and and getters are pretty straightforward. So you might not need to write a huge description of it. If it's doing something with the data, like it's changing it before it gives it to you, then maybe you put in a description of that. And so getName is going to return the name and the type. Right? Cool. So you should do this somewhere, either on the definition or the prototype. We'll talk about prototypes a little bit later, but right now I'm going to just do everything here. But the idea is that you need to be commenting, because as your programs get really complex, especially here, right here, this setter. It's really important that we document that it ignores a lower value than 0. So there's no return. And set. So this is set price. Sets the new price if 0 or if 0 or above. So the parameter is new price. It is of type double, and it is the new price. So something like that. This is really important because maybe your code, people don't want to look at your code, but they want to look at your comments. And if something is weird, like they can't set, like maybe there's a ton of discounts, and suddenly the store should owe them money, and they say, oh no, those toys they're all 0, or they're all the old, the original price without the discount. They would have to look at the code. They could either look at the comment and be like, oh, okay, it's only 0 or above. They can't flip it. Versus them having to dive into your code, which might be very complex, and try to figure out what's going on. So it's really important that you write comments and that you pair them up to all of your functions. And sometimes at the top of your program, you might specify something to the effect of, well, let's look here. Let's look at this example of what we did last week. I put the author, I put my email address, I give the file name, I gave an example of the description, and say that the code is working, that it compiles, there are no warnings, and any kind of comments that I might have. This is really important because this is the first thing somebody sees when they open your program, and if they can get their bearings of whether or not your program is even working or not, or if you think the program's working when it really doesn't, and you say it's working when it doesn't, then that's going to be bad. But if you documented, oh yeah, my program doesn't compile, it's because of this problem, people are a lot more willing to give you credit, whether or not it's actually a course credit, like for the assignment, or if it's like if you're working in the industry and you've isolated your code doesn't compile, but you've isolated why it's not working, and you've wrote that as a comment. That can be very valuable because maybe somebody else is going to take over the job, and that's going to help them narrow down the problem. So a lot of people are honking outside. I don't know what's going on. Okay, cool. So there's our setters and getters. And we've made our privates, and so now we can essentially just make a toy in main. And actually, let's double check that everything compiles. All right, we got hello world, it's all good. So here we can make a toy, and let's call it a Bop It. And let's make another toy, and let's call it Lego. So essentially what it's doing is it's going to make a copy of this class, of this generalized toy, and it's going to call it Bop It. And so now what I can do is I can go in and I can say bopit.set name. Oh, did I miss? Oh, I'm missing one. I don't have a setter for the lowest age. So let's do that. So it's going to be set, it's a void, and it's going to get a new age, so it's going to be an int new lowest age. Cool. And this, we might do the same check. We might make sure that that the person maybe isn't some unreasonable age, and we might also make sure that somebody can't be negative an age. So you do exactly the same thing here. Okay, cool. So, but let's just use the stuff. So, so we're gonna set its name to Bop It, and here let's do Lego dot set name to the string of Lego. And so now we could say we could use the getters now. Oh, let's get rid of that. There we go. We can use the getters to get the name back. So get name, and so we could say, you know, Bop It's name is, and then Lego's name is, Pink. Actually, let's throw a new line in there just to make things nicer. Pink. There we go. Bop It's name is Bop It. Lego's name is Lego. And so this can be really useful because suddenly now we can generalize something, and then we can make copies of that, and then only change the things that are relevant. And you can even set default values for something, so that you could make a toy, and then it has a default name and it has a default price, and as long as you're fine with those defaults, then it's all good. You literally just make it like this, and then you're done and you're good. Maybe you work at the dollar store, that all of your items in your inventory, except for like the posters or something, that you have most of that you only have like a handful of exceptions, that everything costs $1. So you set a default price, and then you just make a ton of toys, and the only thing that you have to, the only thing that you have to change is maybe the name of the product. And then maybe you want to keep track of other things besides just the name and price. Maybe you want to keep track of how many you have in stock or whatnot, or how many are available to be ordered online. You can expand this infinitely based on your implementation. Whatever the context of that this class is going to be useful for, you can make that. So in this case here, it's probably that we're probably somebody who's buying toys for certain kids at certain ages. So maybe we're like a food bank, and it's the holiday drive, and we made all of these classes so that we could store all of the toy selections, so that the family knows what they can pick, and then the price gets that within a budget, and then they're good. So something like that. You can always, contextualizing your data is really important. Knowing how your data is going to be used is sort of necessary. Where does your code fit in the puzzle? Okay, so I think the next thing we wanted to talk about was functions and methods. So there's a difference. A lot of people use them to talk about the other, but they're actually distinct. In Java, everything is a method, because a method is a member function, and it's a member of a class. So in C++, we have things that are inside and outside of a class. For example, main here, main is not inside of a class. But if you look here, the set price and these get prices, these are all inside of a class. They all belong to the class, and they all do something that relates in some way to the class. So, for example, you might have a class inside of the class. You might just have some random function that is called int add1, and takes an int. We're going to call t, and then it returns t plus 1. Whoops, wrong language. Those are curly braces. There we go. So here, in this add1, this is technically a method or a member function, but it's not a good one because it has nothing to do with the toy class. Add1 doesn't do anything. It's not using any of the privates. It's not changing or setting or using any of these privates. So it really has no business being inside of a class. So a method is really good and should be used when it has to do with something with the class. So in this case, let's make that just a function. We're going to pull it out. This is the end of that class here. We're going to pull it out of that class. So there we go. So now it's just a normal function. So a normal function is not inside of a class, but a member function or a method is a member of a class. So if it's inside the class. Also, maybe I didn't want to put get price here. Maybe I wanted to define it later. Maybe there's lots of things that I didn't want it to get too messy. What I can do is I can do this. This is called a prototype, where I essentially say the return type, the name, and then any arguments, and I would only need to put in the types. And I can define them down here. But the way that you know the difference is that it has this scope resolver. It's this double colon thing, and the class name in the front. So this here is still a method or a member function, toy get price, because it has to do with the class, as opposed to add1. Add1 has nothing to do with the class, and it doesn't belong to any class. So just really quick, go over the prototype. So the prototype here is the type, the name, and any arguments if it has any arguments. So for example, if I wanted to make a prototype of this guy here, all I would do is take that and then move this out of it down into here, and then set the scope resolver. And how do I get rid of So, and we don't even actually need to have the name here for the prototype. We just have the type, the return type, the argument type, and the name. And if there are multiple argument types, you just like maybe it takes 2 integers, you would do it like that. Cool. And I would highly suggest keeping the names there, just because it helps people read through your code. And you can choose to attach the comments to either the prototype or the actual definition. It's really up to you, but you need to be consistent. Consistency is really important. Otherwise, it makes it really hard to read your code, because otherwise they're going to have to like scroll up, scroll down, scroll up, scroll down, just to read through all of your comments. Cool. Yeah, so the difference between a function and a method is that a function doesn't have anything to do with the class, versus a method is a member function and it belongs to a class. So it's either going to be inside of a class somewhere. You're going to see it somewhere inside of a class. Cool. Okay, call by value versus call by reference. So David had a really good example of this, and I thought it was funny too. So if I give you if I gave, so call by value is essentially making a copy of the data, versus call by reference is giving you the address of where that data lives. So if I was to call something by like a house, or let's say a building, like Notre Dame, for example, if I was to call by a value, that would be essentially me giving you all the blueprints, and then you make an exact copy of Notre Dame and then stuck it there. And so now, say that I called you by value, and then you burned it down. Is the original still there? Well, yeah, because the call by value is a copy. First, the call by reference is you giving the address of the location, so Notre Dame, and somebody went to that address, the hitman went to that address and burned it down. Is the original still there? No, it got burned down. So the idea is that call by value is very safe because it's always making copies all over the place. That could be bad because it could be taking up memory, but it's good because people can't muck with the data, or if they muck with the data on their own stuff, it's not going to affect the original copy. Versus a call by reference, somebody has like you give somebody an array, they have the ability to go into the array and muck with it. They have the ability to go and change the stuff that's in the array, and that may be wanted or that may be not wanted. So it depends on the scope. Like your medical records. Maybe somebody gets you get a copy of your medical records, and that's perfectly fine. For somebody giving you the reference to your medical records, and you could go in there and change it so that you're an alien instead of a human, right? So the reference has the ability to leak or make something unstable, right? If you have a reference to an object and you're able to go in and change that object to a way that might crash the program, or might make the data that it's storing invalid, that can be really bad. So you have to be really careful when you're allowing people to go in and access your private data. And so to change how we call something to reference, because originally, everything we've done so far has been in value. To call by reference, what we do is we add an ampersand into the into the definition of the function, and also into the prototype. So, for example, here, actually, yeah, let's do that. So let's do an example where we change Boppet. So we have like a string, and we're going to call it Boppet name. Oops. And we're going to assign it to Boppet. And so right now, if we go in here, notice Boppet is Boppet, because what happens here is it makes a copy of Boppet underbar name, and then uses that copy to store it in that class. But now, if I go here and I change set name here, and I put an ampersand here in front of the name, this is now passing by reference. So now what are you going to expect, right? If we get rid of this, if we just do this, it's still going to work. It's going to be, yes. It can't make a copy of this. So notice that it will crash this hard-coded thing here. So there we go. So this is perfectly fine, right? Boppet is good. But now let's put this back, this nopes. Let's see, what's going on? Boppet name set name Okay. Not sure what's going on there. That should be, maybe it's trying to be helpful and it notices that I'm doing this bad stuff here. So let's do something different. Let's print out Boppet's name, and we're going to have the class mutate it. So right now, okay. So right here, we're just setting that. But let's change it as well. So let's say new name equals, got it. Bink. And so notice, got it, right? It changed right here. We print out what the name is. So now let's just get rid of that ampersand and rerun it, and notice it's Boppet. Because what happens here is this is called by reference. So it's giving new name, it's giving the address of new name, and it's allowing us to change it, and it changes that in main. Versus this makes a copy of what's in main, and then we're only messing with that copy, which immediately right here, that copy vanishes. Cool? So yeah, copy by reference versus value. So for the house activity, I'd like you to think about making a class and all of its member functions or methods for a house. So maybe you have how many rooms, how many bathrooms, things like that, and that's on your own. Make all those setters and getters for the house, and send me an email if you have any questions. So yeah, we talked about classes, function methods, call by value versus call by reference, and then hopefully you did the house activity. Yeah. Okay. Bye everyone on the recording.